Hello and welcome to Mr. Franklin Explains Some Math. We have the standard seeing structure in expressions. In this worksheet, we are going to look at what equivalent quadratic expressions look like. Here's the story. When the freshman class officers at Sturgis High School were making plans for the annual end-of-the-year class party, they had a number of variables to consider. And remember, the variables are the things that we don't know the values of. They have to figure out the number of students that are purchasing tickets and attending the party. We'll talk about what that might depend on. The price they charge for tickets. And then a few things that we can figure out, like the expenses for the food, the DJ, and then security and cleanup. Some of these are quantities that depend on how many tickets are sold. Some of them, like the DJ, doesn't matter how many tickets we sell, the price is going to be the same, and the class is going to have to pay it, no matter how many people show up for the dance. A survey of the class members showed that the number of students attending the party would depend on the price charged for tickets. They surveyed the class before asking questions and came up with a little data. They analyzed that data and found that a linear model, like a straight line equation, would give them the number of people willing to attend the dance to purchase tickets depending on X, the price of the ticket. The students responsible for figuring out the price of the food estimated an expense, and it's important to note that expenses subtract from the profit, of $5 per student. That's an average. The students responsible for getting a DJ reported that they would pay $150. Like I said, that doesn't depend on how many people go to the event. And then we have to have security and we have to have cleanup. So the principal of the school gave a price of $100 to clean up and provide security for the dance. So let's think about this. We have a few things that we can figure out now. For example, if we charged $5 per person, we could see that this equation, 200 minus 10 times 5, I'm getting that from up here. This is a linear equation that tells me we're going to take 200 people, and every time the price goes up by $1, we're going to lose 10 people from buying tickets. So the profit for the party would be 200 minus 10 times 5, because if the ticket price is $5, then we're going to lose 10 times 5 people who are willing to buy the tickets. And so this comes out to be 200 minus 50, which of course is just $150. So the party profit, well, we don't have the profit yet. This is just the number of people willing to attend. Let's take a look at what we need to do to follow through on this. So if 150 people attend, they're each going to pay $5 per ticket. And 5 times 150 is 750. So that's the income from the party. But remember that we also have some expenses. What are the expenses? Well, they're laid out pretty clearly here in this paragraph. The first expense is for food, and that is $5 per person. And if there's 150 people, we're going to do 5 times 150. We also have some other expenses. In this case, it's going to be $150 for the DJ. Remember that doesn't depend on how many people attend the party. And we also have to pay $100 for security and cleanup. That also does not depend on how many people attend the party. Let's do the math out on that, one piece at a time. So there's an expense of $750 just for the food, plus $150 for the DJ, plus $100 for security and cleanup. Let's add those together. I get $1,000. So profit isn't just how much money you make from the tickets, it's how much you get to keep after you sell the tickets and then pay all your expenses. So in this case, our income was $750, but our expenses were $1,000. So our profit is a negative $250. That's not very good. If you look at this, you can see that means that if we charge $5, we'll have 150 people come to the party, but we're going to lose money on it. And since this is a fundraiser, I don't think we want to lose money on it. Let's try charging $10 per person. The income in this case is going to be $10. I got ahead of myself, sorry. How many people are going to come to the party? Well, we've got 200 minus 10 times $10 a ticket. So we've got 200 minus 100. What that tells us, if we charge $10 per ticket, we will have only 100 people come to the party. And it seems, just in my head, if people are paying a little bit more, then fewer people will come. That makes sense. But it also seems in my head that if fewer people come and buy tickets, won't we make less money? Well, let's take a look. Try to remember that if we charge $5 per ticket, our profit was only negative $250. We lost money. Let's explore a little bit. The income, if we have 100 people come at $10 a ticket, well, that's going to be $1,000. Remember that before our income was only $750. So now, even though we have more people come, we have a higher ticket price, which means fewer people are willing to buy the tickets. We already have higher income. Remember our expenses. Our expenses are the food. Food is still $5 per person, but now we only have 100 people coming to the party. The DJ still costs $150, and security still costs $100. But if you are following along, you'll see that our expenses are lower this time. In fact, our expenses now are $500 plus $150 plus $100, which is $750 when you add it all up. Our profit, of course, is income minus expenses, or I minus E, we usually say. And in this case, our income is $1,000. Subtract the expenses, which are $750, and we get $250. That's a positive, by the way. Notice that when we charged $5, more people came, but we lost money. If we charge a little bit more, $10, we get a higher profit. And since this is a fundraiser, that's what we mean. That's what we need. And that's a little counterintuitive to me, because that means that if we charge more and fewer people come, that we make more profit. So there's an idea there that needs a little bit more exploring. How could the given information be combined to figure out a price that would allow the class to break even, or maybe even make some profit? So think about that for a second. Somewhere in between charging $5 for a ticket and charging $10 for a ticket, our profit went up. This is a weird word that we're going to see a few times. Break even, a weird phrase. To break even means that you make $0, and that doesn't sound very desirable. But notice that at the break-even point, income and expenses will be the same, so that when we subtract I minus E, we get 0. The profit equals 0. But what that means is that we know that on one side of that break-even point, we're losing money, but on the other side of that break-even point, we're making money. And if we can make a profit by charging $10, what if we charged more than $10? Could we figure out what the best possible price to charge is so that we make the most money? Because if this party is a fundraiser of some sort for the freshman class, we want to make money, right? And so we want to make the most money. So we want to figure out what that perfect price to charge would be. And it's a little hard to just figure that out in our head, because as we've seen, not everything works in a straight line. So let's explore a little bit more. Your job for the rest of this assignment, please read the rest of the instructions. Work out the ideas that we've started here. We've done some of this work already together. Finish filling out this chart. And what you're going to do is use Desmos to make a graph of the different prices we could charge and the profit. When you look at the assignment, the profit is the bottom line of the chart, and we want to graph that against the ticket price. And you should see something familiar. Please insert your graph directly into this document if you can, or just attach a screenshot of the graph. And then using words, using plain English, describe the kind of function or the kind of equation that you would expect to see to model this data well. In the next assignment, we'll explore this a little bit more fully, figure out what the perfect price is and what an algebraic model of this function might look like. Today it's all about the table and the graph though. So please finish up this assignment by making the table, making the graph, and describing what kind of function you see in the table and the graph. Thank you and good luck with the rest of this assignment. I hope these instructions helped.